Good morning, grade 8s. How are you doing? It's Miss Hawaiian here to take you through the next lesson. How are you guys? We are looking at the 6th week of this already. Already? Or maybe it's taken forever. I don't know. Pretty different, but I hope you're hanging in there. Come and visit us in office hours if you have any questions on what you're doing. We don't have too many kids coming in, but we get lots of emails with questions, so do make sure that you come in. We're there to help you have a conversation. And yeah. All right. So week 6, lesson 11, we are into our section 2 of fresh and saltwater systems. So I'm going to talk today about erosion and deposition. And I think actually some of this is going to be some overlap from grade 7. So there's a little bit of this that you've done before, and that'll be kind of nice. Hopefully it'll come back to you. This is a long lesson. So we are going to talk about stream profiles. We're going to talk about erosion and deposition, those processes that basically drive the shaping of our landscape. We're going to talk about watersheds, and in that we'll mention what a continental divide is. All right, so we've got quite a few things to look at today. So hopefully you can describe how water is involved, or what its role is in regards to shaping the planet, moving sediments, picking them up, laying them down in different places, kind of like a sculptor. Okay, so before we get moving, let's have a look at what you did last day. All right, so last day you learned about tides. How does the moon affect tides? You want to think about that for a moment? See if you can answer it. Pause the video. All right. So the gravity of the moon is what's pulling on our oceans. The gravity pulls on the oceans. As the Earth rotates around its axis, the oceans bulge slightly toward the moon as it's moving around and as the Earth is spinning around. So, as a result, we end up with 2 high tides and 2 low tides at any point around the planet where there's shoreline. So let's have a look at this little picture. Should be moving. It should look more like this. And I like this because you get to sort of see the mechanics of things moving. So we're seeing the Earth spinning. We're seeing the moon move around. So remember, the Earth rotates once in a day. The moon, though, is more like on monthly cycle. So it will rotate around ever so slowly. But at the same time, you can see that bulge. When it bulges on one side of the Earth, it's also bulging on the other side. There's something called centrifugal force at work. So it's kind of neat. Anyhow, bottom line, 2 high tides, 2 low tides every day. And they're just about 12 hours apart, 12 hours and about 50 minutes apart. Okay, let's go back. Okay, so we're going to move on, get started here. All right, so let's look at the North Saskatchewan River. What we know about it is that it's fed by glaciers. It's about 1,287 kilometers long, carries a lot of silt. Silt is like sediment or very fine rock and sand. It flows eastward, so it's moving from, let's have a look at this map. I've highlighted it here. So it's leaving from our Rocky Mountain area there, and it's flowing toward, Manitoba. So we've got Edmonton right about here. We see our lovely North Saskatchewan in this photo right now. We can go downtown and spend lots of time around the river valley enjoying that. Then it keeps flowing. It goes into Saskatchewan, and it will combine with the South Saskatchewan River right around Prince Albert. And that place is called the Forks, where the 2 rivers come together. And I grew up in Saskatchewan, not too far from where this is, so I remember going up there and looking at the Forks, and it's kind of a tourist attraction because it's so beautiful. And the water is moving really fast and rushing. And it's just really, really nicely carved into the forest and stuff there. So it's really pretty. All right, it keeps going into Manitoba or North Saskatchewan, finally empties into Lake Winnipeg. But we're going to talk a little bit more later in the presentation. We're going to see it doesn't stop there. It keeps going. So, all right, let's move on. What we just talked about right now is what we call a profile of a river. So a river profile basically includes stream characteristics. Characteristics are anything that describes something. So we're talking about properties. And a stream profile describes the properties of a moving body of water, and you can tell a lot about its conditions and its effects on land especially. So here's our driving question. How does a river change as it begins and ends? And, I'm going to highlight this part, it explains how it affects the land that it runs through. Huge effects. In fact, you can think of water kind of like a sculptor. So it's taking away from some areas, adding to other areas, and eventually really changing the landscape over time. And rivers kind of have a kind of like a story to them, where they begin, where the middle of them runs, and then towards where they end as well. So we've set up this image here to give you an idea of how rivers start, what they're like as the land flattens out, what they turn to be like there, and eventually where they end. So at the start, most rivers begin in mountaintops where there's glaciers. So the glaciers are melting and they begin flowing. And at this point, let's make this a little bit bigger. At this point, rivers are flowing very straight and very fast. Why would they be flowing straight and fast? Because think about the slope of a mountain area. They are quite sloped, quite steep. So the water is just rushing straight down due to gravity. And it's very cold. It's actually really healthy water typically. So at the early stage of a river, that water is moving very fast and very straight. And because of that, it's able to really cut through the rock. So like a stronger force. I want to move down here. All right. At the middle, so kind of the middle, we're calling it that area. So now it's come down from the mountains. It's started to flow still on land that's not as steep and a little more shallow, maybe hilly, but lots of times flatlands too. And because of that, when water is flowing on land that's not really sloped, it doesn't really know where it wants to go. So it's going to go where gravity takes it, of course. But what we end up seeing here is we end up seeing rivers that are no longer flowing really straight, but they start to bend and have curves in them. And we call that meandering. Kind of like students in the hallways when they're supposed to be going to class and they're not sure where to go. But we do miss that. Anyway, so meander kind of means to, move around kind of like a snake-like shape. And because of that, they're not flowing as fast. They might still be cutting through the landscape, but it's definitely not moving as fast. So we see it's starting to slow down, and there's bends as it meanders. That's kind of the middle stage as land flattens out. Now this word meander, it brings to mind some really cool pictures of rivers. Have a look at these. So over time, you've got these big accentuated curves developing from a river. And rivers, I like this bottom corner picture down here. Can't really show you here, I need a new color. This one, because it shows you kind of the curves. So we can see how we've got different colors on the inside of the curves as we do on the outsides of the curves. Let me get a stronger. All right, so we can see like On the inside, we call this the inside of the curve, and this part the outside of the curve. Inside, outside, inside, outside. And you can see like almost sand beds, like some sediment has been laid down, but then on the outsides, this is where it really reminds me of a water slide. So, I mean, the faster you're going on the water slide, when you hit that curve, you usually fly up on the side because you're going so fast. There's more force on you against the outside of that curve. And that's how water's traveling too. Think of the force that it's exerting on that riverbank. And it's starting to cut it out and cut more of it out and cut more of it out. So eventually, if I want to erase this here, I can't. Eventually, these curves might get longer and longer. So here's a neat satellite picture of, I believe this was it's the Nile River. And you can see how old it is. Look at all of the curves. In fact, some of the curves even abandoned parts of the path. These become lakes now. Yeah, here's a little lake. They all look like horseshoes. All you city kids, do you know what a horseshoe looks like? It looks just like that. So it's kind of got that U shape, and they call those oxbow lakes. So it once was part of the river. So lots of movement over time. I love looking at that stuff. Okay, so let's look at the end portion now of the river. As the river is coming to where the end would be that portion of the river that's now reached its final destination. So it might be a lake, it might be an ocean, but it's basically slowed down. It had been carrying sediment and stuff that it had been picking up all along the way, but once water really slows down, it can't carry it anymore. So there's actually a lot of deposits of sand and silt that you find here. And this area has a special name. It even has a special shape. So as it sort of, look at the bottom here where the circle is, as it starts to empty all of its water into that body of lake, it forms kind of a telltale shape of a fan. So a fan kind of has that triangular shape. Well, so does the delta. So a delta is that area where it's spitting out its contents into a lake or an ocean. Most of the solid material gets deposited here. Deltas are near what we call the mouth of a river, and it's where water is moving the slowest. So I think of Delta BC. Delta BC is named that for the Fraser River, which empties into the ocean there, and it's a very large river. Yeah, I mean, they get their names from that. Okay, these areas, because they deposit so many rich minerals and such that they've picked up along the way, you can get some really wide sort of floodplain areas that have really high mineral content. I'm still thinking about BC, but places like Abbotsford, you know, they have a lot of rich farmland because of this sort of, because of these mineral deposits too. So, all right, deltas, the end of the river. So how does water, let's go back to our other question, how does water moving over land affect its landscape? Huge. So like we said, it's like a sculptor, but in order to understand that, we have to look at a couple processes at work. And those two processes are erosion and deposition. So within erosion, we're going to look at two kinds of erosion. We called them weathering, which you could remember from grade 7. Maybe you already know the types. Before I move to the next slide, think about it. What are the two types of weathering? Pause. Unpause. Okay, here we go. All right, so what is erosion? Erosion is the breakdown and carrying away of rock and sediment. So Larger chunks of rock break off due to the force of water. If it's the force of water, then we're talking about mechanical weathering. Mechanical weathering is kind of like, if you took a hammer to something, that force starts to break it down. Physical force. The chemical weathering is another form of erosion, but it's not necessarily by force. It's by water just sitting in crevices and cracks, and over time it can dissolve even rock. So remember, water's been referred to as the universal solvent. Oftentimes water even carries acids, such as acid rain. In rock that's really soft, limestone for example, they can cut into some pretty amazing carvings just by the dissolving action. So more like a chemical reaction. Not a force, but just sitting in it. So we've got two kinds of erosion, or weathering I should say, that help to break down and then start to carry rock to another place. So the water's helping it move. Here's some other kind of cool real-life images of erosion at work. Check out the riverbanks on this top photo. See how it's really started to cut deeper. And then we've got some even larger scale images here with the I don't know if this is the Grand Canyon. I think I assumed that, and I should have double checked, but a canyon of some sort. And we've got, over time, water has just been cutting deeper and deeper and deeper through that. Probably by force. There's probably some wind erosion going on in there as well. So wind is also a force of erosion. And then the bottom picture, this little guy, just a beautiful getaway. It looks like you can see that water is really changing the face of this rock, probably by crashing waves as they come in and constant water movement. So at the shoreline, that's one of the characteristics about a shore. The water is always moving in and out, in and out. So it's making, over time more of a effect on that rock. Moving water is one of the most powerful forces on Earth. As the water moves along surfaces, it picks up sand, dirt, and minerals, and we call these sediments. And they carry them to new places. Okay, taking away and moving it. I love this picture. This is a mushroom-shaped stone that has developed over time on a shoreline in Norway. Pretty cool. Now, I know this part looks like it's gone, right? But it's somewhere else. So it's been moved somewhere. Transported. New places. So what happens when it gets to its new destination? It gets laid down somewhere. Deposition is built on the root word to deposit, and deposit means to put or set down. We deposit money into a bank account, we place it in there. Moving water eventually slows down to the point that it starts dropping the solid particles in the river it was carrying as it flowed. This laying down of particles is called deposition. Fast rivers displace lots of sediments. They have more force, right? Slow rivers displace little. Larger materials usually get deposited first because they're heavy, and the lighter, smaller materials get carried further and dropped last. So think about that river model. Where is deposition happening the most? Where is erosion happening the most? Here's some other real-life examples of deposition. What does it look like when talking about soils and sediments? Well, we've talked about our delta ideas. So at the mouth of rivers, here we've got quite a few little tributaries emptying into the Gulf of Mexico. With that, look at all the sediment that it's carrying and dropping. So you can literally see it kind of coming out in plumes into the water. So it's really spitting out a lot of the sediment it picked up along the way. This one is an alluvial fan. Again, you have that sort of characteristic fan shape, like a typical delta would have. And you can see how it looks like it's just dumped its materials out there. And then this one's kind of hard to see because of the picture I'm in, but even sand dunes. Sand dunes, more because of wind and such, but they're moving and changing shape constantly. So sand is getting picked up and placed in other areas. So a good example of deposition, but here we're more talking about wind, unless we're on a shoreline. All right, so back to our driving question. How does the changing river affect the landscape? So now that you know about these processes, look and see where they're happening. So up near the top, we've got a lot of weathering. Even the weather, the rain, the snow, the freezing, the thawing, all of that can cause rock to break up. And as soon as you've got that moving water and it's starting to carry it, it's eroding and carving out even more of that material. So erosion is happening pretty much from the start all the way till that river really slows down. So right in this area. Now, because the river is going so slow, it's starting to place down what it was carrying. It's depositing. So it's moved it. Rock that was up here, let's get a different color. Rock that was up here could end up all the way down here. And you've just got that changing shape. Again, I'm going back to meandering rivers because they show evidence of both processes at work. They've got that carving out on the insides. No. All right, carving out on the outsides. And we are seeing that here. We've got erosion on the banks as it's cutting into the fresh land there. And then we've got deposition on the inside. There's less force there. So whatever it's picked up and starts carrying, it starts to drop it here, but it's carving out some more around the outsides. And it's dropping them on the insides, but it's carving more out on the outsides. So the older the river, the more exaggerated curves it has. So that's kind of like saying, you know, a younger river is flowing fast and straight, but as it gets over time, it starts to meander. And then you've got really old rivers starting to really meander as they cut into the landscape. Pretty cool. Okay, we're going to switch gears. We're going to talk about what a watershed is. A watershed. Back in the day, watersheds were what they referred to as outhouses. The shed where the water is, it's not really like that. A watershed is the area of land and all its rivers and little tributaries and runoff that empties into the same body of water. Okay, so think about that. Land is very uneven, but if it rains, you're going to have areas that always drain the same way because of the highest points. So the highest points kind of become the dividers. And because of that, we call them the continental dividers. Uh-oh, my pen turned off. So in this picture, this is a great picture. It's actually showing some mountains here. Mountains are very, very high. They're the highest point usually in an area. And because of that, if it rains on that mountain, any rain that falls on this side of the mountain is all going to start running into a central low area. So that body of water is always going to be getting water from the same area of land, unless that landscape changed dramatically. Our watershed, so our North Saskatchewan River, eventually all the water that runs from Edmonton goes into that North Saskatchewan River. And it gets carried eastward to Winnipeg, or Lake Winnipeg. And even Lake Winnipeg drains into the Hudson Bay. So the water that's coming from Edmonton, or we could back up further and we could say coming from the Rockies to Edmonton, through Saskatchewan, into Manitoba, eventually empties into the Hudson Bay. Okay, so let's go ahead and look at some awesome little videos here we found. So the first one is, what is a watershed? And that one's really, it just simply outlines what exactly it is. The second one says, where is your watershed? And that one is more around where we live. So that one's awesome. It takes you through sort of the length of the river. And then the third one I really liked because it looks at more of the science behind it. Water management, how it's important, and just lots of different things. So I couldn't cut any of these out. So please make sure that you look at them. They're great. You'll walk away and know exactly what a watershed is without any confusion. All right, so you can't really talk about a watershed without also mentioning what a continental divide is, because the continental divide is exactly what determines where the watershed is. So I took this straight from your textbook because the textbook explains it really well. So, continental divide. The location of the highest land point on the continent determines the direction that a watershed drains. This high land is called the continental divide. In North America, the major divide is in the Rocky Mountains. To the west of the continental divide, river flows into the Pacific Ocean, so into BC. To the east of the continental divide, river flows either into the Arctic Ocean or the Atlantic Ocean, so more north. And then the borders between BC and Alberta and Yukon, they all follow this continental divide. So it made sense to make the divisions along those land areas. And here's Canada's 5 major watersheds. For any of you who've been in my room, I have this poster at the back of my classroom. This has always been up. So these color codings match the 5 major watersheds and their divisions, so their dividers right here. If I'm looking at the Pacific Ocean, what do you think the continental divide is right there? We've got the Rocky Mountains, and that runs down into the United States as well. And then we've got this little divide. Clearly, along that division point, that's the highest area of land. So that means if it falls on this side, it's going to run this way. If it falls on this side, it's going to run this way. And eventually all goes into the Hudson Bay. So everything here is going into the Hudson Bay. Everything here is ending up into the Arctic Ocean. Everything on the left, our west side, is going into the Pacific. If I move this up a little bit for you, then we've got the Atlantic on the far right. So everything that falls beyond this border is going into the Atlantic Ocean. So those are our 5. Oh, I forgot the last little one. This little one just barely touches into Canada, but anything falling south of that goes into the Gulf of Mexico. So we even have water that will eventually end up in the Gulf of Mexico. All right. Huge, huge lesson. We talked about a lot of things. We talked about stream characteristics. So those characteristics that make up just, all the little bits that you know about a river, where it comes from, how fast it's flowing, what it's carrying, where it's going to go, what feeds it, essentially. Erosion and mechanical weathering, chemical weathering. So basically the picking up, breaking down, picking up, and carrying of sediment. And then we looked at deposition. Deposition is that laying down of the sediment. So maybe at the mouth of a river or wherever water is traveling very slowly. Then we looked at watersheds, the area of land that all drains into a same shared body of water. And the continental divide is that highest land point that determines where the watersheds separate. Lots of things. All right, major vocab from today just included erosion and deposition. And looking ahead. All right, what's coming up? Okay, so your next steps are going to be to go back into your own Google Classroom for science and do the assessment that's there. It'll be week 6, lesson 5. No, wrong. Week 6, lesson 11, I believe. Why did I have to... let's go back. It'll have the same heading as this guy. Yeah, week 6, lesson 11. If you have any questions, come into office hours. We'll help you out. We are there between 10:45 and 11:30 today, or 1 p.m. to 1:45. All right, so on Monday, we're going to have the topic of ocean basins, continental drainage. So we're still looking at how substances are moving and changing shape of the land. All right, that's it for today. All right, stay well. We'll see you.